Hey guys, welcome back to my channel. In today's video, we're going to see how to solve this problem called delete leaves with a given value, right? So it's an easy question. It's marked as medium, but trust me, it's an easy question, right? So let's read the question. Given a binary tree root and an integer target, delete all the leaf nodes with the value target. Okay, so note that once you delete a leaf node with the value target, if its parent becomes a leaf node and has the value target, it should also be deleted, right? So you need to continue doing that until you cannot delete. So what that means, so let's say a tree is given to you. This is the tree, right? So here leaf nodes are these, right? These all are the leaf nodes, right? So target is given, that is 2, right? So this leaf node is a target and this leaf node is also a target, right? So what I'm going to do, I'm going to delete this, right? So now this became a leaf node and this is not a leaf node. Why? Because this has some children, right? So this became a leaf node and this also has the value 2. So I will delete this also and then I will check for this whether this is a leaf node or not. This is not a leaf node. So finally this is the output. This is the output, right? So now let's look into the approach, right? So the approach is very easy. You will just do a recursion and then while coming up on the way, you will be solving these nodes, right? So what I'm going to do, I'm going to go for a DFS and then I'll go to the depth. I will go to the depth. If I found a leaf node, I will check it with this value. If it is true, then I will delete this. How to delete this? While coming up, I will return null. Right? So this value, like whichever is sitting here just above this, let's say this is the value, this will get null from the left hand side. If it gets null from the right hand side also, that means this is a leaf node, right? So this will check with this 2 again, and if it is equal, it will also return null, right? So while going up, I'm actually solving this problem. So let's have a look at this example, how I'm going to do. Right, so see, when I'm standing here, I will say, bro, get the value from the left hand side, get the value from the right hand side. Then I will go to the left hand side, right? Then I will say, bro, get the value from the left hand side, get the value from the right hand side. Then I will go to the left. Then I will say, get the value from the left hand side, get the value from the right hand side. This will be null, this will be null, right? So if both left and right is null, that means it's a leaf node, right? And if the value if it is 2, that means we need to delete it. How to delete it? We can just replace this with null, right? Replace this with null. So what I'm going to do, I'm going to return null. So left pointer of 2 will become null, right? So similarly this will be null, so left and right of 2 will be null, right? So again it's a leaf node and the value is 2. So I'm going to delete this also. How to delete? I will just return null, right? So left side of 1 will be null and it will go to right hand side, it will go here, then it will get the left and right side, right? Then it will go here, left side will be null, right side will be null. It's a leaf node and the value is 2. So I will delete this. How to delete? I will just return null. Then it will go here, left side is null, right side is null, so it's a leaf node, but the value is not 2. So I won't return null, I will return this value itself, right? So 4 will come here. This 3 will be having left as null, right as 4. So it's not a leaf node. Go up and I'm returning this value, that is 3, right? So 3 will come here. So for 1 will be null and 1 will be 3. So it's not a leaf node. So we don't have to check for 2 also. So I'm just going to return this root, right? So this tree will become something like this. So let's write the code first of all. If the root value, if it is null, I'm just going to return null, right? And root of left, bro, bring me the answer from sub problem, right? Bring the answer from root of left, like go to root of left and then bring me the answer, right? So this will be having the answer from the left hand side and this also will be having the answer from right hand side, right? So sub part of root of right. So now I got left side and right side. Then I will simply check if root left, if it is null, if it is not there, and if root of right is also not there, and root of val, if it is equals to the target, then I will say, bro, this is a leaf node with the value target, right? With the value target. So I will simply return null, right? So I will simply return null, right? So this is all about the code. So let's look into the code, right? So it's the same thing that I have just explained, right? So if the current node, if it is null, that means I will return null. And then I will go for the left node, and then I will go for the right node, right? So root of left will be storing what? I will say, bro, this sub problem, go to left and get the answer. So root of left will be going next along with the target and then get the answer and store it in the root of left. Similarly, root of right will be going for the right side. So subproblem of root of right along with the answer will be passed and get the answer from the right hand side. After getting these two, I will check whether the left hand side and right hand side are null or not. If they are null, that means this portion is saying that the node is a leaf node, right? That the node is a leaf node. And if the value is equals to target, then I have to delete it. How to delete it? I'm just returning null, right? And if it's not satisfying this condition, I will just return the root itself, right? So the time complexity is basically of n for DFS, and then space complexity is of n. Why? For a skew tree, depth of the tree will be in the code stack, right? So the code stack will be of O of n size. So time complexity is of n and space complexity is of n. That's it for today's video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.